Let's learn about special quadrilaterals. So the first special quadrilateral we're going to talk about is a rectangle. And a rectangle is a quadrilateral, which means it has 4 sides, and every angle is a right angle. So the question is, are rectangles parallelograms? And the answer is yes, because remember that if both pairs of opposite angles are congruent, then the quadrilateral must be a parallelogram. So every rectangle is a parallelogram. Our next special quadrilateral is a rhombus, and a rhombus is a quadrilateral with 4 congruent sides. Okay, does that mean that a rhombus is a square? No, because if it was going to be a square, then these would have to be right angles, and a rhombus does not have to have right angles. Are rhombuses parallelograms? Yes, because both pairs of opposite sides are congruent, so every rhombus is a parallelogram. And a square is a quadrilateral with 4 right angles, just like a rectangle, and 4 congruent sides, just like a rhombus. So a square has everything that you need. So it's a parallelogram, it's a rhombus, and it's also a rectangle. Okay, so here's our first theorem involving special quadrilaterals, and it says that the diagonals of a rectangle are congruent. Okay, so I've got A, B, C, D, and we want to show that AC is congruent to BD. Well, I know that this side is congruent to that side because opposite sides of a parallelogram are congruent. This side's congruent to that one, and this angle is 90 degrees as well as this angle. So if I pull out triangle ADC, I've got that side and that side, and if I pull out triangle BCD, that side is congruent to that one up there in that angle. So I have side, angle, side. Do y'all see that? Side, angle, side. So therefore, by CPCTC, I can say that AC is congruent to BD. Our next theorem involves a rhombus, and it says that the diagonals of a rhombus are perpendicular. Well, how are we going to show that? Here's how it works. I'm going to draw my diagonals, and by definition, all the sides of a rhombus are congruent. Okay, so here's A, B, C, D. So if I took segment AC, and here's point B up here, remember that these two sides are congruent. So what do we know about points that are equidistant from the endpoints of a segment? They lie on the perpendicular bisector. Okay, so that's why the diagonals of a rhombus are perpendicular, because the diagonals are actually perpendicular bisectors of each other. So each diagonal of a rhombus bisects 2 angles of the rhombus. Okay, so what we're saying is if that's A, B, C, D, then these angles are bisected. Okay, well, how do we know that? Well, these sides are congruent, right? And they share that side. So by side, 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 triangle ABC is congruent to triangle CDA. So by CPCTC, these angles are all going to be congruent to each other. Okay, this theorem says that the midpoint of the hypotenuse of a right triangle is equidistant from the 3 vertices. So since this is the midpoint, then we know that that's congruent to that. So we've got those 2 pieces congruent, but how do we show that MG is the same distance? Well, what I'm going to do is draw 2 sides out here. So what I do is I create a rectangle now, okay? And complete that diagonal. And remember that the diagonals of a rectangle are congruent and they bisect each other. Therefore, all 3 pieces are congruent. Therefore, MR is congruent to MI is congruent to MG, which means that this point, if I've got a right triangle and there's the midpoint. That midpoint of the hypotenuse is equidistant from all three vertices. Okay? And finally, if we're given a parallelogram and we know that two consecutive sides, two sides that are next to each other, are congruent, then it has to be a rhombus. Well, remember that if it's a parallelogram, opposite sides are congruent. Hey, look, all four sides are congruent, so therefore, by definition, it's a rhombus. Okay, time for some examples. We're given that quadrilateral SLTM is a rhombus, and that means that all these sides are congruent, and all these angles are bisected by the diagonals. So I've got angle 1 congruent to angle 2, and I'm told that angle 1 is 3x plus 8, angle 2 is 11x minus 24, so that means that 3x plus 8 must equal 11x minus 24. Let's add 24 to both sides and subtract 3x, and I get x is 4. Okay, and here we're given that GM is a median of right triangle IRG, so that means that M is the midpoint, so that's congruent to that, and that's congruent to that. So you notice that what I have here now is an isosceles triangle right here. Okay, which means that angle 3 and angle 4 have to equal each other by the isosceles triangle theorem. So that means that 7x minus 3 must equal 6x plus 6. And if I add 3 to both sides and subtract 6x from both sides, I get x equals 9. Last example, the coordinates of 3 vertices of a rectangle are given. Plot the points and find the coordinates of the 4th vertex. And then we're supposed to answer the question, is the rectangle a square? Okay, so point O is at the origin, 0, 0. So there's point O. Point P is at 0, 5. We don't know where point Q is. That's what we're supposed to find. Point R is at 2, 0. Okay. So to make a rectangle, I'm going to have to go straight up from R and straight across to P. And that puts point Q at 2, 5. Is it a square? No, because these sides are 5 and that side's 2. So it is not a square. All right.